Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all these questions one by one. Students, let us solve the next question, that is question number 14. The particle moves with simple harmonic motion. So it is a question on SHM. Simple harmonic motion in a straight line in first t seconds after starting from rest. It travels a distance a. So starting from a means starting from rest means what? Suppose this is the mean position, x is 0, and this is the extreme position, x is plus a, and this is extreme left minus a. So the particle is oscillating between these 2 points, these 2 extreme points, plus a and minus a. So where the motion starts? In first t seconds after starting from rest. We know that in SHM the particle comes to rest momentarily at the extreme points. So we will consider, suppose that this is the right extreme, the particle starts its motion from here. Starts its motion from here with initial velocity 0, because this is a position when the particle is at rest. So that means the motion is starting from extreme right position. So okay then, and it continues to travel for travels a distance a. So it is traveling a distance a. So distance. So suppose that this is the distance it travels, and it has certain velocity, and this is the distance it travels, and the time taken for this is t seconds. Next, then in next t seconds, then again in next t seconds, it travels a distance 2a. So in next, suppose this is 2a. Suppose this is 2a. So this this distance is traveled in next t seconds. So from here to here t seconds, and the distance travelled is a. From here to here, the distance travelled is 2a, and the time taken is tau. Now in the same direction, so therefore it is in the same direction. That means it is not returned from the left extreme, so it has to move only in that particular direction. So the distance is insufficient to cross this point and then turn back. Then the amplitude of motion is, so you have to find basically the amplitude of motion, time period of oscillation, amplitude of motion, time period of oscillation. That means you have to find two things. One is your amplitude of oscillation, that is a, you find, and you find time period t. Out of this you solve for a and t and see which one of the following options is correct. So how to solve this question? Because we know the basic idea that when a particle completes or makes oscillation, then the total time period is t. That means from whichever point you start motion, suppose from here right extreme, then it comes to the left extreme, then it comes back to the same point again, then it is called one time period. Now as it is starting from here, I'll write the equation for the displacement of the particle is because this is the displacement, this is not the distance. This is a displacement which is measured from the mean position, always is measured from the mean position. The general equation for the displacement of the particle in SHM is given by x equal to a sine omega t plus alpha, where alpha is called the initial phase. Alpha is the initial phase. So now from where it starts its motion, from extreme right. So initial phase will be 90 pi by 2. So if I put pi by 2 here, I'll get the displacement corresponding to that equation will be the equation for the displacement of the particle when the motion starts from extreme right position. So by putting alpha equals to pi by 2, I will have a situation where the motion is starting from here, the alpha is pi by 2, and then the displacement equation for the particle starting from here is given by x is equal to a sine omega t plus pi by 2, which is a cos omega t. So this a cos omega t is the displacement equation for the particle. Now it says that it travels a distance a. So in t seconds, in t second, it travels a distance a. That implies, so this distance is a. That implies what is the displacement? The displacement will be, if you measure from here, the total distance is a. So that means this is the displacement. So for this case, the displacement here, I'll call this, suppose this is x1, and that displacement is equal to this total a minus a, because from out of this total a, this total distance is a, and you subtract this will get the displacement, because the particle is somewhere now here. So the displacement is a direct line joining from the mean position to the position where the particle is after a time t seconds. Now this is displacement, and that equals to, because that is the equation of x, a cos omega t. So this is equation number 1. Now again, in next t seconds, the particle again is at covering a distance 2a. So I will use another color to distinguish that, so that you can distinguish the, from here it is suppose coming to this distance, this is suppose this distance is 2a. Okay, the distance 2a. Now the particle is here, so the displacement is from here to here. This is the displacement. So in the second case, after the time in next t seconds, the distance covered is 3a. The total distance covered here is 3a, because we will consider this is the displacement, and this is the distance. Total distance is already covered, a plus 2a, that is 3a. So a minus 3a will be the displacement. So that means the displacement in the second case will be a minus 3a, which is a cos omega t. So here the t is tau, I should put tau, and now here it is 2 tau, because after 2 t seconds starting from, if I count this distance, then I have to consider this time also, tau, 2 tau. After 2 tau it has covered a distance 3a, so I will put 2 tau here, the distance is ta, this is about the distance. This is the distance it covers in the corresponding time. So here it is at 2 omega tau. Here also it is, you can put tau, okay, because time is tau. So in place of time you put tau. Here time is tau, here time is 2 tau. So I will put 2 tau directly. So this is equation number 2. Now if I solve the equation, how to solve this equation to get the value of a? That means this is an equation consisting of a, small a, and cos of omega t. This is also cos of 2 omega tau. Now how to eliminate this cos omega t something? So we have an expression like, you can see from here, I'll write from 1, I'll write a minus a divided by a comes out to be cos of omega tau, because I put t equals tau, this is 1, and from here I'll get a minus 3a divided by a equals to cos of 2 omega tau. Now we have one how to eliminate these two. Okay, now if I consider this as theta, then this will be 2 theta, and cos 2 theta and theta cos theta are related like this. 1 plus cos 2 theta, 1 plus cos 2 theta is 2 cos square theta. So if I use this expression, then after you have that relation, that is 1 plus cos 2 theta is 2 cos square theta, this relation you have to use. So in this case we have 1 plus cos 2 omega tau, this is equal to 2 cos square omega tau. So I will substitute the value of that cos 2 omega tau, which was a minus 3a divided by a. Similarly, to cos square omega tau is a minus a by a, that we got from the previous equation. So squaring it, and you have to solve it to get the relation between a and a. Now to solve that, now I will separate this, or make a simplification. This is 1 plus 1 minus 3a by a, 1 plus 1 minus 3a by a, that equals to 2 into 1 minus a by a the whole square. Okay. Now from here you have got 2 minus 3a over a, which is equal to 2 into, this is a minus b the whole square, a minus b whole square is a square plus b square minus 2ab. Okay. Now I have to multiply this 2 inside and rewrite the equation. 2 minus 3a by a equals to 2 plus 2 is multiplied to this 2 a square by a square. This 2 is multiplied, this is minus 4 a by a. Okay. Now now this 2 and this 2 will cancel out, and this 4a will be brought to the other side of the equation. This will be 4a by a, this will become plus, and this is minus 3a by a, which equal to 2a by a the whole square. Now 4 minus is 1, so it is a by a. This implies that, I will use another phrase, this means that 2a by a the whole square equals to 4 minus is a by a. This is what you got. Okay. So from here, so this is what you got, and now okay, so I will get 2 of a by a the whole square. One will cancel out. A by a equals to a by a. So a is brought down here. So it is a by a the whole square is a by 2a. Okay. So if I substitute, then 1 x a by a will cancel out, because this is a by a into a by a. This is a by a. 1 a by will cancel out. This will be a by a, and this is 1 by 2. From here, a equals to 2 times a. Okay. Now, if I see the option, the amplitude is 3a and 4a. It is not 2a. So these two options are not correct. So then we have to look for the time period of oscillation. So then, how to find the time period of oscillation? To find the time period of oscillation, we know that time period of oscillation t equals to 2 pi by omega. Now, how to get omega? To get omega, we have to use the equation. Any one equation you can use. We can use the first equation. What was the first equation? The first equation was that a minus a by a is equal to cos omega t. That equation we'll use. You can see here. This is the first equation. This equation you can use to find omega. A minus a by a equals to this. So a minus a by a equals to cos of omega tau. So now if I put the value of a as 2a, then this is 2a minus a by 2a is equal to cos of omega tau. 2a minus is a by 2a, so 1 by 2. This is 1 by 2. This is cos of omega tau. Which value of cos theta is half? Cos 60. So this cos 60 is half. So omega tau is pi by 3. Pi by 3. So from here you have omega as pi by 3 of tau. So if I have omega as this, I will substitute this omega. I'll substitute this omega in the equation, general equation, that t equals to 2 pi by omega. This is the time period of oscillation. So t pi by omega, and omega is how much? Omega I got pi divided by 3 tau. This is what I got just now. You can see the omega is 3 by pi by 3 tau. So pi by 3 tau will come to the numerator. So this pi will cancel out. This is 6 times tau. Now this is the time period oscillation. Now if I see the options, you can see here time period of oscillation is 6 tau. So this is the correct answer to this question. Time period is 6 tau. Okay, thank you.